I'm going to share some quick updates on a few, 3 different features that are going into 2.0. And if you've been to the recent working group meetings, you've probably already seen this, but all right. So the first one is shared strings and virtual dataset mappings. So in most use cases where people use a virtual dataset, assuming they have more than one mapping, generally those mappings will all either share the same source file or the same source dataset name. It could be the same source dataset name in multiple files or a bunch of different datasets in the same file. And so, and if there are a lot of mappings for a virtual dataset, then this can get pretty expensive. Both in terms of the disk usage, because you need to store the same string n number of times, and also because of potentially memory usage, and also because of the time it takes to copy the layout structure internally, which ends up happening a few different times through the course of using a virtual data set. So we want to try to optimize that so that we're not copying the same information, a very large number of times when we only really need to do it once. So we're introducing a new change both in how the library works internally and in the file format in 2.0, where we will detect these repeated strings both when they're being added by the API and when they're being decoded from the file, and we'll sort of just share buffers. I don't want to say a memory or a reference counted buffer, because we at least as far as I've gotten in implementation, I don't think reference counting is actually necessary internally, but it's a shared buffer shared by all the different mappings, a single buffer, so that when you copy it, you don't need to actually do a mem copy of the buffer every time. In addition to this, we're also adding a new version of the file format that will do a similar analogous thing in the file. And so that instead of storing the same string every time, it also just store basically a link to where to find the string. And so they're very analogous, although it does get a little more complicated because in implementation, because there are cases where you would want to use the optimized format in memory, but not in the file. But conceptually, this is sort of the same thing. And we're also adding some optimizations for the case where the source data set is in the same file as the virtual data set. Right now, we store a string that's just a period, and it has to be that string. It can't be null or anything like that. So we're going to allow null, basically, and use it internally so that we're not copying this 2 byte long string everywhere. So that's any questions on this feature? All right. And then so the next feature I'm going to talk about is fine-grained vault capability reporting. So we have vault plugins are essentially re-implement large sections of the HDF5 library, and it's not realistic to expect all of them to recreate all the features of the native HDF5 library in all cases. And there are some we have these capability flags that allow some sort of very high level reporting of what features are and aren't supported, but it can't possibly cover all the different enumerated combinations and all the small cases that could be supported or unsupported by different vault connectors. So we're in order to sort of extend that, we're going to extend the meaning of HRT, the standard return value, and also similar things that also have an error return like HTRT or things like that. Because right now, it's any negative value is considered a failure, and we always in practice return -1. So we have all these other numbers that we can use for other things. So we're going to use another number, probably -2, and assign a macro to it, that means it's a failure, but it's a special, it gives you more information on the failure, like an error no or something. So it tells you that this failed because the vol connector does not support this feature or this specific this feature with this in this case. And so this this extension occurs both at the in terms of what a vol connector returns to the library from the vol callback, and in terms of what the library returns to the application. And so this should be backwards compatible, because if applications haven't been updated to make use of this, they're just going to see a negative value and consider it an error, and handle that appropriately. And vol connectors will just always return failure if they haven't been updated. Always return failure for unsupported operations, but it does allow applications to handle unsupported connectors differently, and critically allows the automated testing to handle these unsupported cases more gracefully. So it'll just report something as unsupported instead of reporting a bunch of failures, and then you have to go in and in order to make it pass, you need to go in and manually skip certain tests for specific vol connectors. It just is a maintenance nightmare. So it's mostly about greatly improving the testing, and they allow outside developers to use our test suite without needing to modify it or ask us to make a special version of the test suite for their vol connector or something like that. So basically open up vol testing to the world. So any questions about this feature?
Yes, Neil. So what is the recommendation for vol creators when to use -2 versus extending capability flags or shrinking capability flags?
So you should use the capability flags wherever wherever it's appropriate, wherever it just completely describes what you support and what you don't support, like it. But for like the more so if you partially support something, you should set the capability flag that you partially or completely support something. You should set the capability flag that you support it. But for the partial cases, then you use for the partial cases, if you run into something like a more specific case that isn't supported, like for example, you support sorting by creation order, but you don't support sorting by creation order in reverse alphabetical order, then you return, in that case, if they ask you to do that, then you return -2 and don't do anything to the file. And I suppose if the library asks you to do something that you say you don't support by the capability flags, you should also return -2. Although that shouldn't happen. If that does happen, that's a bug in the library.
Right. The library shouldn't make that call then.
Right. Yeah, the library should see that, and then the library should return -2 to the application.
Right.
Mm-hmm. Okay. Thank you.
Yep. Any other questions? All right, so then I'll move on to my third item I was going to talk about today. Is H5D read chunk 2. This is probably the most important one for people that, for the general public. So we're adding a new version of the direct chunk read function, H5D read chunk, which you may be familiar with this. Its purpose is to sort of read a chunk directly from disk without going through any caches or any intermediate layers or any filters or any data type conversions. It just, you pass a buffer and it reads from disk directly to that buffer, and that's all it does. Well, it also needs to make sure that the cache stays consistent and things like that, but for the most part, that's all it does. And we found an issue with the signature the HID read chunk function. Basically, it accepts a buffer, a read buffer that it reads a chunk into, but it doesn't accept the buffer size. So the library doesn't know what the buffer size is, and so for HID read, it has a similar signature where it doesn't accept the buffer size. But for HID read, it's not an issue because the needed size of the buffer is well defined by the data, the extent of the data space, and the size of the data type. It's very simple to calculate exactly how big that buffer needs to be by multiplying those two things. But for HID read chunk, because the chunk can be filtered, which can change the size of the chunk, there's no easy way, easy I mean in terms of performance, there's no easy way for the application to know how big the chunk is on disk. So I think in practice, most people probably just allocate the unfiltered size of the chunk and pass it to HID read chunk, but it's possible for a filter to grow the size of a chunk. So in this case, what ends up happening is the application passes a buffer that's big enough for the unfiltered chunk, and then the library gets this buffer, which is just a pointer. And remember, a buffer in C is just a pointer to the start of the buffer. It has no information about where the end is. And so the library gets this pointer, and it just happily reads the number of bytes, the entire filtered chunk to that buffer. And if the filtered chunk is larger than the unfiltered chunk, then it writes past the end of the buffer, which is a big no-no. It's memory error, potential security vulnerability. And the only way to avoid this with the current API is to, before you call HID read chunk, call one of the HID chunk get chunk info or something like that. There's a function that goes and queries the size of the chunk, and you would have to call that before every single notification of HID read chunk, which it kind of defeats the purpose of HID read chunk, which is to do everything with as little overhead as possible. But all of a sudden, you're adding in this extra metadata operation before every single invocation. So that's a major overhead for something that's whole reason for existence is to completely aggressively minimize all overhead. So to get around this, we've introduced a new version of HID read chunk, HID read chunk 2, using the standard versioning scheme where the function names are now HID read chunk 1 and HID read chunk 2, and HID read chunk is a macro, and it gets assigned to one or the other depending on your preferences. And this signature, I have it here. It's it's like HID read chunk, but it also takes this buffer size parameter. And so basically, you can you pass it a pointer to a variable that has the size of your buffer, and on the exit, that number is set to the needed buffer size. And if it wasn't big enough, then it doesn't read anything. And then you just use that buffer size that you get back to allocate a new buffer or reallocate it, and then call it again. And so we strongly encourage anyone using HID read chunk to move to HID read chunk 2. And so the advantage of using HID read chunk 2 over the get chunk info followed by HID read chunk is that that you can allocate a buffer that you're pretty sure is big enough, and then you're only doing one pass into the metadata because it internally HID read chunk 1 and HID read chunk 2 will both query the metadata to find out the size of the chunk. And the advantage is that now you only have to do that once as long as your guessed buffer size was big enough. And if it wasn't big enough, then you have to do it twice, but that should be very rare. as opposed to having to do the query the metadata twice on every single invocation, no matter what, to be safe.
Neil, question. It's really confusing what you said. Because if I have about the purpose of buff size, so if I have filtered chunk on the disk, first of all, probably library can provide an API that will give me sizes of.
Yes, that API exists, but people that want to use HID read chunk don't want to call it before every single invocation of HID read chunk because it adds overhead.
Right, so it returns for, say, all sequence of chunks, but this is not the point. So library can provide better optimized API, more efficient API than calling it every time if you're reading by chunks. So for example, if you have fixed size data set and you have so many chunks, why not return an array with sizes? But then when I read the chunk, it is filtered. I need to know its size. I still need to successfully uncompress it because I don't know where my data is if I read in the bigger buffer. So how that will work?
I'll have to double check, but I believe that the size is returned in buff size, but it.
Okay.
I wasn't aware of people that were having that problem because that would be a problem with HRD read, the original HRD read chunk. No, HRD read chunk 1.
But this is why they were using that call to find the size of the chunk, right? And they allocated the buffer, they read, they know that all data is the real data and not some fill values in that buffer. And then
right, but this way it takes an optimistic perspective in a computer science way, an optimistic perspective that says, I will try, and if I can't, I will let you know so that you can try again.
No, if buffer size
it defers the second read to exceptional cases instead of the every case.
So what you are saying that buffer size, it's in-out parameter, and it will return you the real size of the.
Yeah, I'll have to double check that it returns the real size in the case where it succeeds. I'm pretty sure it does.
Yeah, because if it doesn't, it does make sense. But if it does, yes, it's fine. It's a wonderful API.
Right.
Mm-hmm.
Well, if it doesn't make sense, then it didn't make sense. I guess
before too.
Yeah, but you at least can guess that your compression is good, that it doesn't blow up your buffer, and you can estimate the size of the chunk by using data type size by size chunk. So at least in 90% cases, it will work.
Right. Yeah, that's the optimistic take on it. Yeah, exactly.
Yeah, but it should be in-out parameter. Otherwise, we're back to square.
It is an in-out parameter.
It has to be an in-out parameter. Okay. Otherwise, it wouldn't be a pointer. But okay.
Thank you. Oh.
Yeah, for the original version of this API, I wanted to have a separate parameter for the buffer size and for the chunk size, in for the buffer size and out for the chunk size. But I went with this basically to match the same pattern that we used on some existing APIs.
But how it will help with security if you're not you're providing. You are not providing, say, anything because it will accept null pointer, I guess, or it can, or
at the API level, it won't allow you. The buffer size is required. You have to pass the buffer size.
And API checks that. So only the okay.
And you can pass a null buffer, and that way you're basically just querying the needed buffer size. It allows that.
I see.
Thank you. You have to pass the buffer size pointer.
Okay, thanks.
All right. Any other questions? All right. So that's all I had for today. Thanks everyone for coming. And I guess we'll see you next time.
All right. Thanks, Neil, for stepping in. See everyone next week.
Thanks, Neil.
Bye-bye.